Look at that. Your lesson gets to start like that every day. All right, so we're going to take a look at getting rid of your T-chart. And so what we are going to do is we're going to go ahead and just take a look at these parabolas that are there. And what I want you to realize is, if I look at my vertex, so if I start at my vertex on every single one of these, there's a pattern that's always going on. And so when we were graphing, and I'd be like, okay, you're going to do the calculations and stuff, you would type in the calculator and go, and sometimes I would too, just because I wanted you to see that I would type it in too. But really, I was just looking at a pattern, and I knew where the dot should be based off that pattern. So if I look at my vertex right here, this shows me that if I go 1 to the right, I go up 1. If I go over 2 to the right, it goes up 4. And if I go 3 to the right, it actually goes up 9. And so I'm not going 9 from here. I'd be going straight across and up. I just want you to see those numbers. But every parabola follows something like this. And so you see we have a different function here. This is x squared plus 2. If I start at my vertex, it goes 1 to the right and up 1. And this goes left and right because of symmetry, right? So I could go to the left and see the same thing. If I go 2, it goes up 4. And then I go over 3 and it goes up 9. So there's nothing too crazy there. If we slide down, you'll see that it works for negatives as well. So I got negative 2 times x squared. In the middle here, I got negative x squared. And if I look at this negative x squared first, we'll see that the pattern continues, but this time it's just making me go down 1. If I go 2 to the right, I'm going down 4, and if I go 3 to the right, it goes down 9. And so the last one I'm going to show you is this one. This one goes over 1, it goes down 2. This one goes down, or to the right 2. How far down does it go though? I want you to actually count it out. How many does it go down? What you got, Chase? Count. How far does that go down?
8.
Look at that. Yeah, it does go down 8 times. So I just told you there's a pattern where it goes 1, 4, 9. But now we're looking over here and it went 2, 8. And let's count this last one. Every one of you, count it out. How many is that really long piece going to be? It's not 9. What you got, Aiden? 18. Yeah. How does 2, 8, and 18 relate to 1, 4, 9? How does 2, 8, and 18 relate to 1, 4, and 9? It's all doubled. Look what's attached to the x squared. So that number in front of the x squared is the only number you actually have to worry about. So we have this pattern. I'm going to possibly slide. I might come right back. Yeah, I'm going to come right back. So we have this pattern that goes like this. For every shift you go to the left or to the right, it does the same thing. It always goes, if I go 1 to the right or left, it goes up 1. If I go 2 to the right or left, it goes up 4. And if I go 3 to the right or left, it goes up 9. Now that change is only based off of A. So you can actually always say that this is times A. And so in the first couple of examples I showed you, A was 1. So it didn't really change anything. The last one I showed you, A was negative 2. So if I times all these numbers by negative 2, it's telling me that I go 1 away from my vertex and I go down 2. I go 2 away from my vertex, I would go down 8. 3 away, I would go down 18. And so we can use this pattern to kind of get rid of the T-chart. Now, I don't care what you use. If you use the pattern, I need to see this. You can't just put the dots out there and call it good. Okay, I want to see where those dots are coming from. If you use the table, you just got to show your work. Okay, So this is just an option for you to look at. And the biggest thing about this lesson is it is something for you to think about and be like, does the parabola I just graphed make any sense? And if it does, that's like a quick little check you can do to help yourself out. Now, I'm going to put 1, 2, 3, 1, 4, 9 back up on the next slide. Okay, so you can utilize it when we start doing these problems. So you can see 1, 2, 3. I'm going to put 1, 4, 9 there right away, but then I'm going to put times whatever A is. And what is A in this problem? Come on. 1, yeah. So if it is times 1, I don't need you to write times 1. I'm writing it so we can see where this is coming from. Okay. But otherwise, you can write this down, and you've done enough to graph it once you know what the vertex is and once you know what the axis of symmetry is. So remind me, and you can look back in your packet, how do I find the vertex or the axis of symmetry for something that I cannot factor that's in standard form? What do I use? What formula? Look back. It's in your notes. It's highlighted on here. It's printed for you. That's how I know you all have it. Awesome. Thank you. So x equals negative b divided by 2a. So that tells me my axis of symmetry, and it's telling me the x-coordinate of that vertex. So let's calculate it. You calculate, I'll calculate, or I'll get an answer. -2, okay? Work out. Okay, let's go ahead and plug that in. So I'm going to have f of -2. So I got -2 squared plus 4 times -2 and plus 6. Give me a number for that. Type it in. Push those buttons on those calculators. What did we get? 2? Head shaking yes. So I would just go ahead and plot this point. So -2, 2. And then I'm going to use the pattern. And this is how nice it is. So you can absolutely make a T-chart. If I made a T-chart, I would do the ladder like I normally do. So I put my vertex in the dead center. That'd be at -2. Remember that once you know what your vertex is, you go 2 up and 2 down the ladder. So I could say this is -1 and 0, -3 and -4. We plug all those numbers and get our answer. Or if we use the pattern, I just come over to my vertex and I go 1 to the right and I go up, in this case, 1. So I go 1 to the right, put a dot. I'm also going to go 1 to my left and put a dot. Then I look at my next one. It says I go 2 to the right or 2 to the left, and I'm going to go up 4. So this is the most important thing. You have to go to your vertex. When you graph lines, you go from the next dot and continue the pattern on. You don't do that here. You go ahead and you go back to your vertex, and I go 2 to the right, and I go up 4. Then I go 2 to the left, and I go up 4. How many points do we need? 5. Yeah, so since we need 5, I don't even have to look at this one. And that's very common. I'm never actually probably going to look at that last piece. I'm normally only going to use these first two, and then I go and draw my parabola. What is the concavity on this parabola? I heard like a sigh that sounded like oh, so I take it. All right, so concave up. And remember, we're just looking at the arrows here. Any questions on that one? Let's slide to the next one. You find the vertex for me. You've been doing that for a few days now, so you don't need me to help. I will put our formula right there, though, and I'll give you a head start. What do we get for the axis of symmetry? We get what? 3. Perfect. I'm also going to put that for my vertex as well. And then let's go ahead and calculate. Watch the sign on the square. It should be on the outside of the parentheses. What do we get for a number when you type it in? What you get? 25. You're correct. That's a good assumption. So we got 25 as an answer. Any other answers?
7.
7?
Yeah.
All right. Any other answers? Anyone get 7 or 25? I got one other person who got 7. Okay, a couple more. All right, I got some hands. That's good. It should be 7. So what I'll say is watch that sign because this ends up being -9 because we square it. We get 9. The negative gets tacked on. This is plus 18 and then -2. So 7 does end up being the correct answer there. So we can plot that. So 3, 7. And you notice this time I'm actually doing the pattern last. And so I'll write out 1, 4, and 9. And really think about that. All this is saying is this is like your x coordinate, this is your y coordinate. If I take 1 and I square it, I get 1. If I take 2 and I square it, I get 4. 3 squared, 9. That's why the pattern works the way it does. Now, what is A? What number is represented there? -1. So you have to times every single thing by -1. And so the pattern then states that I'm going to go 1 to the right, I go down 1, 2 to the right, I go down 4, and 3 to the right, I go down 9. That's what the negative is telling you. So plotting that always again at the vertex, and then going back to the vertex, I'm going 2 to the right and going down 4. And then I use symmetry to get the remaining points. Concavity, what are we looking at? Yeah, down. How do we feel about the pattern? Good, bad, something? Anything? Good? All right, again, you don't have to use it. You can go back to a T-chart and say, I know my vertex starts at 3, and then I would use the ladder and I would count up 4, 5, count down 2 and 1, and I would plug those points in to get the remaining points. So nothing too crazy there. Any questions about any of this? All right, I'm going to the next slide. Does anyone need more time? I'm going to give you 5 minutes to try this problem out. See what you can do. I'll leave the formula up. Talk together, work together. Keep them on slow. That's right. So you should be getting kind of a weird decimal there, or a fraction, for the axis of symmetry. So I saw in a lot of people's paper that they had -9, and then 2 times 3. So realize that this 3, that first term, is what A is, and that's also telling you what to plug in for your pattern, so I would have times 3 as well. So it goes both in the pattern and in our formula, and so we actually get positive 1.5 or 3 over 2, however you want to write that. So I'm writing it both ways because I'm fine using either of those fractions. are we getting for our vertex? It's going to be a fraction. What's the y coordinate going to be? Compare with someone. Compare with someone next to you. See if you got the same thing. If you did not get the same thing, type this in. All right, I'll start. It's going to be negative 8 point what? $8.75. If we're struggling to get that number, just watch your parentheses and watch how you type it in. I honestly will type this whole thing in my calculator. I don't break it up at all. There's no point, okay? Just type it all in. So I have this, and this is really not nice. So I'm going to go halfway between 1 and 2. I'm going to go down to 8, and then go pretty dang close to 9. So I'm a quarter of the way there. And then from that dot, I'm going to follow the pattern and do these two things. So this is telling me I'm going to go 1 to the right. I'm going to go up 3. So 1 to the right actually puts me at 2.5. And then from there, I'll go 1, 2, 3. So I'm at like negative 5.75. And I'll put the other corresponding dot there. And then it's telling me to go 2 from my vertex. And I'm going to have to go up 12. So from this dot again, I go 2 over. So I'm at 3.5. And then I'm going up 12. So there's 3. So I got a dot right there. And then that's going to push me for symmetry over there. What is our concavity? What'd you write down? Oh, good. What questions do we have? We looked pretty good as I was walking around. The only thing I really want you to focus on is just realizing that this formula right here, that A is right there. And a lot of us did a good job of identifying it for the pattern, but then we put like -1 like we did in the last problem. So just watch out for that. Any questions?